A very warm and pleasant good morning to all the distinguished guests, respected convener, organizing secretary, and director GGSE STC, Professor Dr. Priyadarshi Jaruhar sir, our today's resource persons, respected Shri R.R. Jaruhar sir, IRSC member, Railway Board, retired, Gurugram, respected Professor Dr. A.W. Kharche sir, Director PDVB, Kotle College of Engineering, Malkapur, and respected Professor Dr. R.P. Verma sir, Dean Academics and Associate Professor, GGSE STC Bokaro, respected Coordinator, Dr. Yasir Karim sir, respected Co-Coordinator, Dr. Manojit De sir, respected faculty members, researchers, and our participants. It gives me a great pleasure to welcome you all to the second day of ISTE BNY Knowledge Enhancement Program 2026, an online faculty development program on environmental and geotechnical engineering, hydrogeology, waste management, risk assessment. Now, with the divine blessing of Goddess Saraswati, let us begin with FDP session with the Saraswati Vandana. I request Professor Apurva Sinha ma'am and Mr. Anil sir to start the Saraswati Vandana, please.
तो श्वेत वर्णी कमल पे विराजे, हाथों में वीणा मुकुट सर पे साजे। तो श्वेत वर्णी कमल पे विराजे, हाथों में वीणा मुकुट सर पे साजे। मन से हमारे मिटा दे अंधेरे, हमको उजालों का संसार दे माँ। हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ।
Thank you, ma'am. Thank you, sir. Yesterday's session provided us with valuable insights and enriching discussions, and we are sure that today's session will further enhance our knowledge and understanding about the subject. Now, I request our respected director, Professor Dr. Priyadarshi Jaruhar sir, to welcome everybody. So,
good morning, namaskar, johar to all of you in this enlightening session. I welcome on behalf of Guru Govind Singh Educational Society Technical Campus and on behalf of IST New Delhi, of all of you to contribute in this session, either as a esteemed resource person or our respected faculty members and participants. Today, we have a very eminent personality, Sri Rajiv Ranjan Jarwar, IRSC officer, have a very wide experience in Indian Railway, and he is a author of many books also, particularly related to Indian Railway, Railwayman, and other books published, and it is one of the best seller. in the field of civil engineering and railways. And I personally recommend all of you to must read book. It is a must read book. Okay, not taking much of the time. I welcome all of you. And this session is very important because we will be able to understand the faults, mainly how a fault happens in a structure. And Mr. Jarwar is a bridge specialist also. He had contributed in this nation in many of the difficult bridges like Brahmaputra River in Tejpur, the bridge is very strategic also. It is contributing, it is defending country now from various hostile countries which we all know. And at the same time, the Gandak bridge, which is very, very difficult to make these bridges because due to the different water flows, and God willing, these bridges are working very well today also, and many people every day have a relief of crossing this difficult rivers, particularly in rainy season. It is almost impossible to cross this bridge. Being a citizen of Bihar and Jharkhand, and once I resided in Bhagalpur, and I was working as an engineer in Nepal in textile mill. At that time, there was no bridge in Bhagalpur, Purnia or Naugachia. So we had to cross. We have no option other than to cross Ganga River by either country-made boats or a small, you can say, launch. So, not taking much of the time, I I just plead to all of our participants to have a very concentrated listening, and if possible, they can write important things, figures, understand that our future engineers, budding engineers, which are being taught in various engineering college, particularly in civil engineering, they can understand the basic fundamentals of faults and risk involved in a structure. Thank you. Thank you very much. Once again, I welcome all of you, particularly Mr. R. Chandra. Jai Hind.
Thank you so much, sir. Now, I'm very pleased to officially introduce and welcome Sri R. Jaruhar, sir. Mr. Jaruhar graduated in civil engineering in 1966 from BIT Sindri. After a stint of 2 years of assistant professor, he joined Indian Service of Railway Engineers IRSE in 1968. He has a long distinguished career spanning more than 39 years in Indian Railway, during which he occupied many important posts including Divisional Railway Manager and General Manager of Northern Railway, Secretary Railway Board. He finally retired as Member Engineering, Railway Board and Secretary Government of India in January 2007. Mr. Jeruhar is credited with construction of 3 kilometers long bridge over the river Brahmaputra 1979-86 in Assam. As chief engineer, he also completed bridge over the river Great Gandak 1990-94, which included massive river training works over 8 kilometers wide river. A general manager Northern Railway and subsequently as member Engineering Railway Board. He spearheaded construction of 343 kilometers railway line in Jammu and Kashmir, considered as huge engineering challenge in the world. It also included the world's highest rail bridge over River Chenab. He is also credited with modification and restoration of over 2 kilometers long Pamban Bridge across Rameshwaram Creek. His innovation concept of probabilistic model in allowing higher LX loading on mixed traffic routes in IR paved the way of introduction of heavy haul leading to huge turnaround of IR with huge revenue surplus of rupees 12,000 crores. IIM Ahmedabad, ISB Hyderabad, Harvard Business School made it research subjects. He was also chairman of Public Sector Unit, Railway Vikas Nigam and Konkan Railway Corporation. He was also in the panel of International Arbitrator of Union International of Railway. He has also been its consultant of infrastructure improvement. He was the team leader of Greek of Aircon's rail line project. He was technical consultant of the World Bank, technical advisor of L&T Construction Company and MS Sistra MVA. In India, at present, he is an international infrastructure consultant. He has served as chairman or member of several technical advisory group and expert committees set up by Government of India, like for construction of rail bridge over River Ganga near Ghazipur, Allahabad, and BG line from Rishikesh to Karnprayag, a major engineering challenge. He was chief technical advisor to National Capital Region Transport Corporation for the Rapid Rail Transport System. He was also the chairman of the Expert Advisory Committee for Mumbai Ahmedabad High Speed Rail Project. He has been awarded the Prime Minister's Gold Medal for Brahmaputra Bridge and Railway Minister's Medal for Brahmaputra Bridge and the Aircon's Algeric Project. A visiting lecturer at Indian School of Business, Hyderabad on public-private enterprises. He is motivational speaker on social behavior, spiritual awareness, leadership, project management, and business communications. He was trained in UK in managing large-scale projects and has many technical papers on his credit. And last but not the least, he has written 2 books, A Railwayman and Engineer's Memoir and Follow the Railway, published by Rupa and greatly acclaimed. Let's welcome Mr. Jaruhar, sir. We welcome you, sir.
सर आप
महमूद
म्यूटेड हैं।
महमूद सर आप पीपीटी स्टार्ट कर दें प्लीज।
ओके
आशीष सर स्टार्ट कर रहे हैं सर पीपीटी। हाँ स्टार्ट हो गया है, सर को अनम्यूट कर दिए हैं।
ओके थैंक यू वेरी मच सो आई कैन स्टार्ट थैंक यू वेरी मच गुड मॉर्निंग ओम शांति and I particularly welcome all the participants whom I can see virtually. Of course, for engineers, virtual is not a very unknown entity. We all know about virtual energy and virtual work. I'll try to take all of you to a path where you will be able to at least perceive the subject of structural engineering from the design and construction point of view in altogether a different light. So that will be my attempt. The title of the slide, Development of Concept of Structural Engineering, is a very loaded subject. I mean, you would like to wonder what does concept in structural engineering would mean and how that concept has to be developed. This is my key to the presentation. So please try to understand and appreciate it. I'll try to explain this from a definite example. When we were doing on Indian Railways heavy haul project, meaning that carrying heavier train than what was being done. So the axle load was very important, and because of the higher axle load, what is the stress developed in the rail was the important factor. So briefly speaking, the track is designed, or rail stresses are calculated as a beam on elastic foundation, all a rail resting on number of sleepers, beam on elastic foundation, and it has a track modulus. Just like when you design a beam, you try to find out what is the section modulus of the beam, which will calculate the stresses in the rail. We were using a 60 kg rail, 90 UTS. That means 90 kg per square millimeter was the ultimate tensile strength. Now, when we started, this was being attempted for a long time. And the stress in the rail, our people calculated, was more than 90 kg per square millimeter. And therefore, they said that it is not safe to increase the load. But when I started going into the depth of I questioned them that why are you using a track modulus, which is as old as when I joined the Indian Railways in 1968, the same track model. Now so much of modernization has taken place, and this has changed. They said, sir, we don't know any other track modulus. This has been using, and nobody asked us that why you are using the old formula. Nothing can be done. But The point was that they were using 9 factors. One is the vertical load of the rail, then the longitudinal forces on the rail, and different type of temperature variations, hot, cold, contraction, all that, 9 factors. And they were adding every one of them algebraically and finding out 92 kg per or 94 kg per square millimeter, greater than 90. I said that once this formula is wrong, then how you can use everything algebraically? So from this developed a concept that when we are treating a structure which has been designed with so many assumptions, the bending moment theories itself having so many assumptions. For everything, the material of the rail has got so many other variables. So with so many assumptions, how it can be that 90 kg per square millimeter, stop anything 90.1 is off, go, no go. It cannot be like this. So there must be a range of stress. That means a variation of when you put on a probability curve of a standard deviation, it can have a range of about sigma. If you take it, can have a variation of about 2 to 3% of the average. So we demolished the standing poll of go or no go. We said that up to 394, 93 is okay. So it should have a variation of plus minus 3 kg per square millimeter, 4 kg square per about 4%. Okay. So this I call it as a concept. Develop this concept from a deterministic model of 90 plus 0.1 is no, 90 minus 0.1 is yes. No. So it will have a range. So this is a concept. So we went into a probabilistic model, and similarly bridges. When I checked up the bridges, said that if you add this load, it will become unsafe. How much unsafe? Already existing was 200% over stress. I said if it's 200% over stress, the bridges should have all fallen down. It has not fallen. Every bridge is first class. So 260, why should it fail? That means you are getting either not getting so much of forces on your structure, or the method of your calculation is incorrect. So, ladies and gentlemen, with this example, you will understand that why should we take a structure as a not a deterministic sort of a thing, but it will have a range from this to this. It should be all right. Not that if I calculate the reinforcement as 3.24, I'm sorry, I'm old days used to FPS system. In our days, in in my days of engineering college. That time you can answer either in FPS or CGS. Both were you're allowed. The question was also in FPS, and so I keep on making that mistake. So kindly correct it. So supposing it is 3.28 inches square, and you get 3.3, it is not a failure. Something like this. So what I'm trying to say that it will have a range. So the concept development will mean that the structure will have a range. So I'll develop further how you can make this whole thing um, ponder over it and never dismiss anything just on the what has been given in the code of practice. The next one, please. Is the slide visible?
Yes, sir, visible.
Okay. Now, the objective of the presentation is we must understand the importance of a structure and its basic function. What is its requirement? You know that French people, they call theory of a structure as poetry. And any piece of a structure they will call oeuvre d'art. That means the work of art. What I'm trying to say, I'm very grateful to our teacher who instilled in us that look at this structure as a kind of a poetry. That means, what does poetry mean? Poetry is a mental expression. A poet visualizes things and expresses it in words. Likewise, if you look at the structure today, the structural analysis or whatever you are going to do, it will be some kind of a mental thinking that how the structures behaving, bending, and how. So for him, the deflected structure is much more important than a simply bending moment diagram or something else. So we'll try to acknowledge that the structure is very important. Its functional requirement must be kept into view. So this we will presently see. Then understand what is the basic behavior of a structure. And any structure is built in a particularly in a natural surrounding, and nature has a profound impact on the health of a structure. So it is very necessary that one should observe the surrounding in which the structure is going to be situated. For example, whether it is an area where it is going to be eroded, whether it is going to be built on a high altitude, whether it is going to be built on a corrosive atmosphere, whether this structure is going to be built on a high tidal river. I mean, I'll explain that why people overlook this aspect led to the failure of a structure. Then understanding applicability of the code and engineering appreciation. We should understand, we will try to understand that what is going to be applicable. The code of practices will list out 10 or 12 forces. Shall we add all these 10 or 12 forces? We find out, we'll try to find out or interpret that what are going to be applicable. For example, when you design a simple slab, and you say that the dead load will be the weight of the slab which you are putting. Live load will be 150 kg per square something. Those are the things which are going to be applicable. Wind may not be applicable depending upon where the structure is going to be situated or what is the height of the structure. So we have to make a distinction, not like in our case, all the factors are added in algebraics. Then learn from the known failures. Failure is not taught in engineering colleges. Everything is safe. We have to understand that how failure takes place. If you know how failure takes place, then you can take action against to thwart it. If you do not know how the failure is going to take place, I think you will have cut a very sorry figure. I'll also try to give you that how people ignored the signals of the failure and which led to the disaster. And so therefore, what is important that an engineer, when he goes to the site, he observes the structure very, very carefully. As a doctor is, examines a patient, you should examine and see. And lastly, most important is develop insights for the most optimum cost-effective and durable design from the point of view of construction and maintenance. Very simply stated is the word durable, cost-effective, optimum. Very, very, I think it sounds something like this, that it should be done. But the overriding aspect is insight. That means I should develop the ideas in my mind that what should I do to develop to have a optimum design, cost-effective structure, and durable from the construction as well as maintenance. So these are the few objectives of this one. So we will see about them in my presentation later on. Next one, please. Next slide. How I have based this presentation. My own experience in learning and teaching of structural engineering, long experience in construction and design of some of the major important structures in India and abroad. Some pictures are there. There's the Brahmaputra Bridge on the right-hand side. And then the next picture is abroad in Algeria. It constructed long bridge on a very, very deep viaduct. And I have been the so many committees have been asked to help to develop what should be design parameters of a particular design or particular structure, or what troubleshooting can be done. So I have been, say, for example, for this Namo Bharat, that is Meerut Delhi rapid rail transport project, we developed for it that what should be the design parameters for designing the rail system. That means for bridges, for tunnels, when the train moves at the speed of 200 kmph, that its oscillation and vibrations. So all those clearances required for the train to move on, what we call moving dimension. So on that will depend upon the design of the size of the tunnel, etc. So and also for this Mumbai Ahmedabad, we didn't have a standard for 350 kmph train also. So we developed or prescribed that these should be the standards for the design of the. And although Japanese were trying to, they designed the main thing, but those things were to be adopted for the Indian system. So we developed, we worked in between them. And lastly, my learnings through interaction with some of the legends in the field of structure. I give credit to all my gurus. I mean, I don't know, these days, people do not talk about legends, people who have worked for so many years. In our days, persons like late B.C. Ganguly, B.C.A. Padmavan were legends. Every word which they speak will say that you should do this, should not do that, and explain why should it be done or why should it not be done. So I had a valuable, great opportunity to work with them, and they virtually taught me. In fact, when I was doing this Brahmaputra Bridge, I told Mr. B.C. Ganguly that, sir, I do not know how to deal with this huge, massive river. So he told me that since you say that you do not know, that means you will be able to do it. The person who says that, "Main to sab janta hu, I know everything." So proceed from the point of view that you have to learn. Then you will go to the lowest man, a foreman also, or a inspector also, to learn that how a particular thing is to be done. Next, please. Now, a basic definition of the structure, I'll just briefly say, is the, concrete, steel are the basic construction material. We should know, and also the earth or the soil, we should know the basic properties of these materials. And we have read it in building materials, etc., etc. I think it is a good idea to revise those and the literature available on this. So I should know the basic properties of a high tensile steel when I am constructing a cable stayed bridge or the pre-stressed concrete. But I should know that what are the its properties. And likewise for concrete is a very, least understood construction material. A concrete is a combination or the aggregate of cement, coarse aggregate, fine aggregate, and water. And what are going to be the different proportions is a wonderful subject you should know. That means for a constructing a particular part of the say girder, what kind of concrete you will need. It is not necessarily the same type of concrete will be used everywhere. For example, in this Brahmaputra bridge, the depth of the girder was 8 meters. And 8 meter is a kind of a single room. And how to pour concrete from the top, and the concrete has to go from all the corners of the box girder. So its concrete design has to be different. So try to understand the problem of the what should be the slump, what should be the permeability, and factors like the concrete can segregation. These things you should understand. I think so. Some knowledge of the concrete technology is very, very welcome. Then, for the geotechnical part of it, the most important feature is grain size. In construction of a bank or this thing, even for the foundation, you should be very, very conversant with that. How to read a soil mechanics, a borehole log test has been done by the geotechnical experts. How to interpret those results? You should try to study and interpret. And these are all simple knowledge, but correlate these knowledges. Then a structure designed and constructed to serve a particular is very important. Functional requirement is so that why I am going to construct this structure. There is a very famous example. Somebody constructed a staircase and he forgot to construct the landing, so nobody can enter the room. Functionally, it became very, very useless. So you should know that what is the purpose of constructing this. A structure must be designed and constructed to conform to the nature or follow natural laws. Try to understand each word of it. What does it mean, natural laws? Example, if you are supposed to carry a bag of, say, vegetables, 10 kg bag, how will you carry? You will try to carry it as close to your body as possible. No? If you can carry it like this also, but not for a long time. So a structure which is being built, because these against the nature, these as per the nature, as close to the center of gravity of the system. If you do not follow this natural law, the structure is bound to fail prematurely. Another thing which happened in Manipur, there's a railway line going to Imphal, and a big gorge. And we recommended that you should construct a bridge over this one. But somebody had a brilliant idea. He said that इसमें कोई पानी वानी ज़्यादा आता नहीं. So he filled up and made an embankment across the gorge and made a very small opening. In 2 years' time, it fell. Against the nature, you cannot change the natural surrounding of the terrain. This is very important. So this is a shining example. They after it had failed, they came back to me again. तो हमने कहा ये तो हो गया होगा, बड़ा किस तरह ऐसा कर दिया. हमने कहा तब क्या फिर ऐसा क्यों किया तुमने? Then a structure must be functional. Functional means they constructed an airport line and DMRC, Delhi Metro, from Connaught Place to airport, 16 kilometers line. I was also the director of their board, and there were 9 stations in between. I told the managing director that with 9 stoppages, that means the interstation distance will be less than 2 kilometers. So you will never be able to achieve a speed of 130 kmph. Why are you calling it a high-speed line? You will never be able to achieve. This function is, but talking to people who do not know, 130, high speed. Finally, it did not run at 130. There were other things also, which I will describe later on. And ultimately, that line is today running at 65 kmph. There was no need, but what has happened? Imagine all the curves were designed for 130 kmph, and you run a system with 65 kmph. Consider the amount of the force coming on the inner rail. It is the centrifugal force cannot be balanced. A very, very inferior design. So one should see that it is not possible. You should not do it. Next, please. This I'm going to make in a passing that how the early design, it was all in the early part of civilization. The main purpose was for the purpose of food, water, and sheltering, and self-covering some clothes. And the food was, they used to kill animals, and that was their food. And then they developed agriculture subsequently and used to live in a cave or under a tree. Look at the shape of the cave or that, all were conical. That means the CG of the system was at the center, and that structure was most safest. And they stored water, and what they used the skin of the animal which they killed as for their covering. That became part of textile engineering subsequently. They learned at what kind of, how the text can be, even the food which they started growing, how to use the byproduct of it for covering their bodies. So early structures you see are all very bulky and conform to nature, like pyramids, go and see Kunal, very huge structures. But subsequently, when these scientific knowledge developed, they learned the laws of uh, the scientific laws to design a more economical aesthetic structures. The most important, in my opinion, was Newton, who developed the formula of force. He defined that how force can be defined, and also the momentum, and Hooks, who developed a stress-strain relationship. Uh, both were very, very, I think, for engineers, very important. Very funny, Hooks was senior to Newton. Hooks was the president of the Royal Society of Physics, and after Newton, and both were constantly quarreling with each other. When the Newton took over from Hooks, he removed all the pictures of Hooks from the lobby of the Royal Society of Physics. I went to Cambridge. I saw the Newton's laboratory where he worked. The most funny thing was he used to have a small notebook. One of the entry in the notebook was 10 p.m. went to pubs, have a beer, spent 2 pence, something like that. They used to spend whole day and night at. Next, please. Now, we come to what should be the basic concept in design and construction. The structure must serve as functional requirement. For example, the bridge is meant to cross a obstruction and must be simple to construct, should be economical and suitable for a location, either a long span bridge or a types of foundation. And this I've purposely made it because many times today you will find people will use long span bridge, which is where it is not necessary. They're spending so much of money. But when I want to have a cable straight bridge here, long span, why a long span bridge where it has to be provided? Otherwise, have a simple construction. Should be easy to maintain and durable. Now, the stark example of this one is Patna Ganga Bridge, old bridge. They provided a hinge at the center of the span. Actually, this bridge was being constructed when this Brahmaputra bridge I was doing. It was 3-4 years earlier they had started. We started 4 years later. So I used to often come to Patna to see how this work was being done. So I questioned at that time that why are you providing a hinge at the center? If you hinge, it's very difficult to maintain. Long time, the passage of traffic, the hinge will get blocked by the dust and everything. It will stop functioning. It become loose, and then the entire elastic behavior advantage which you wanted from a hinge will be lost. Exactly, it has happened like this. Whereas we did not provide a hinge, we provide a simple supported span and an expansion jar at both sides. Now this work is perfectly all right, working without any problem. Same type of span, also same. All construction must conform to design assumptions. Note this, design is what have you assumed in the design? That must be realized in construction. This is very important. I'll show you it in the next slide, please. Next. Shall we go to the next slide? Next slide, please.
Sir, your slide is not passed.
It's not there.
Yeah.
DMRC Moolchand line. No. Okay. Anyway, it is not there. Okay. This Moolchand flyover. Hello. This Moolchand is not there.
Sir, slide is
Okay. Let me explain. I think this can be given to them subsequently. It is a L-sept, a pier with a L-sept, and the top of it, the girdle is coming. And if you see the fixity between the L portion and the vertical portion, it has not been very proper. Sorry. That means in design, we assume that these two L-sept will be 90 degrees. That means it should not bend like this. And in whatever this angle between the vertical limb and the horizontal limb should be 90 degrees. This is what was assumed in the design. But if you do not allow the fixity to take place, this will rotate. This is what has happened. So it cracked. Actually, during construction, I had pointed out that when I saw it, I said that ठीक नहीं लगता. Have you seen people diving in a swimming pool from the? It is a kind of a springboard.
yes, sir. Yes, sir.
And if you apply the load there, it will go up and down. And particularly if a moving load is moving on it, ये ऐसे से करेगा. So it cannot be this kind of a design is absolutely unfit for a kind of a load which is being supposed to be carried. So on the right hand side of this, I have shown that it is, if you use it like a T-type retaining wall, provide a heel at the rear and reinforcements which will stop it from rotating. This junction design is most important. This is what has happened there. It's failed because of this one. And why it has happened? Because somebody only calculated the bending moment and so much moment, so much of steel, so much of this thing. But designing the joint so that the fixity takes place was not done. So my emphasis on this one is design your joints properly. I will go to the next one. हाँ ये तो है मूलचंद. Okay. Can you see it now?
Yes, sir. Now it is visible. Yes, sir. Actually, synchronously, it is not past the slide.
Oh. Anyway, can you see it now? On the right hand side, on the left hand side, you will find there is nothing to prevent the top one and the vertical one to rotate. And on the right hand side, you see there is a diagonal bar going out, which prevents the diagonal shear to rotate the joint. This is the very important, and the heel acts as a kind of, it will not allow it to rotate. We use typical our T-type retaining wall design, typical. Very simple would have been just to make it as a triangle. Triangle is the most stable structure you must all be knowing. Make a triangle there. So everywhere, whenever we deal with it, we create a triangle so that the triangle of forces, this diagonal shear will be taken care of. I have got more pictures of joints subsequently, and you will try to appreciate it. So I will request all of you to study this, and this should be the part of the training, that they must pay attention to the joints. Shall we go to the next one, please? Importance of observation in structuralism. What I've said that already, that must be very good observer, should be able to visualize the structural behavior, deformation with particular reference to the geometrical properties. This is another classical design. U-type girder on the right hand side. All of you have read or understand the center of gravity of this U-type is in the air. It does not fall inside the body of the structure. So it will vibrate very, very badly. And so it happened in the airport line. And all the bearings and these pedestals all cracked. So never design this kind of. Have you seen an angle, simple angle, being used as a beam? Why? Because its center of gravity it falls outside the main body of this one. You can use a double angle joint back to back, but not a single angle. Or for that matter, even a channel used as a beam is not double channel back to back. It will work for first class. Bring this CG into this one. Then location of a structure is very important. Normally, the evidence of existing structures provide very useful inputs for this design. I mean, see that any structure which is in the vicinity of the area where you are going to construct something should be observed. A tree, for example, how is the slope of something? What if some structure has been built, how it is behaving? Look at them. Our people are so bad observer these days. I am very sorry to say that very senior people, they refuse to go and see that what the recent case of Narmada, not last year's case. The there was a they were constructing the bridge for the high speed line Ahmedabad Mumbai, and that bridge foundation had collapsed. They wanted me to help it, so I had gone there. I was aghast to see that how they are designing this structure. A very premier contractor of the country. Problem is that they consider that we know everything. Now, Narmada is such an important river. There are hundreds of gauging stations. You know exactly what is the discharge of this river. And this location where this bridge was being built, only about 100 meters above is a railway bridge. They could have seen that what type of foundations have they provided. That bridge is about 100 years old. I asked them that why did you not do it? He said that ki wo to humne dekha nahi. Can you accept such a lie? And then it was affected by the tidal very near Surat. So I said that the confluence of this river is 50 kilometers down. It is going to meet the sea, not this near Surat. And so the tidal effect will be there. You were not aware of it. So that was a very important thing. Like this, the river tones for this heavy haul line, they were having problems with the structure. So I had gone in there, and I see that nothing else is required. What have you done is to protect the slope of the embankment by protecting the toe of the embankment. That is all which is needed. And because by the side of the river tones, there were long, high trees, 100 years, 60 years old. I said, they have not fallen. That means this river is having no problem. Likewise, Gandak, where we are constructing this Gandak bridge, on the upstream, there was a spur. We went there and found out what is the cover of this one. So I think what I'm trying to emphasizing it, go and see. Next one, please. Code and practices. There's several types of codes. I have the good fortune of dealing with all types of codes in my international exposure. So, but one thing is very important is that they are all general guidelines. उसमें जो loading दिया हुआ है, they are all hypothetical. They are not the actual loads. And very important is that you should know as an owner of the structure what kind of loading you must choose. This is your right given in the code. So we chose that one. Say this one is a on the right-hand side, you see Pamban Bridge. The president had asked me once that, because the railway had decided earlier that the Madurai Rameswaram line will stop short of Rameswaram because of this Pamban Bridge. It used to lift to allow the sea traffic, and it was a meter gauge line converted to a broad gauge. So it was not suitable for the broad gauge loading, so it had stopped. The president asked me that, Mr. Jarwar, you kindly go and see. So I want that a person, I remember his words, who goes to Vishwanath Baba, he should be also able to go to Rameswaram and offer Ganga Jal to Rameswaram. So I had gone and seen, and we decided here that our most important requirement is to take a passenger train. So let us put the loading one by one, actual passenger train loading. Then we found that passenger train loading is okay. Then we went to the next higher, supposing we take a goods train with normal food crane, cement, etc. That was also okay. Coal also okay. Then what was not possible was a mineral like limestone and iron ore, etc. I said that Rameswaram does not need iron ore and limestone. Food grain, cement is okay. So we curtailed that loading, and this bridge was retrofitted. So I went and told the president that, sir, it will not be able to take limestone, but it can take all normal kind of a loading. He was very, very happy. Brahmaputra, we designed the box girder, and it was sent to IIT Madras for the proofing. Dr. Raja Gopalan, the head of the structural engineering department, he told me that this design is failing under 2 class A loading when the flood is the highest. So मैंने कहा सर मैं आता हूँ, I'll come. I went to Chennai. I told him there is no need to, with class AA it was okay, because tension was developing one corner. According to the code, no tension should happen at any stage of loading. So I told him that Dr. Rajagopalan sir, ये ऐसा है कि when recently Assam में the flood took place about a month ago, with the high flood level of 86.8, all traffic, all roads were submerged and no traffic could move in Assam. And now you are making it, our high flood level was 87.4. 87.4 में तो कहाँ कोई जाएगा, सो वहां पर AA लोडिंग कहाँ लेकर के जाएगा. Class AA is okay, so it is impracticable, so let us not do this. I mean, the bridge is functioning perfectly all right. And Buckland Bridge in Calcutta, we had developed first time. I was working those days in 1974 on board piles. Board piles were at that time the diameter used to be 760 millimeter only. Now it is 2 meter diameter. So when we tested for a small it's according to our file code, 1.3 meter from the top has to be treated as a cantilever. तो उसमें fail हो जाता. I said that no, why should you not take the passive resistance? Because it was in a Howrah yard. That portion is not going to be washed out any time of this. It's life of the bridge. So, and I took only 20% of this one, and this bridge is first class. So, I am making a concept and trying to apply it to solve this problem. Likewise, this local site conditions like, say, Ganga Bridge at Sangam, that near Allahabad, which has been cleared by us, being constructed now. I didn't know that Ganga meets the Yamuna there, and Yamuna carries 39,000 cubics, Ganga carries is about 28,000. So, whenever Ganga is in flood, Yamuna will work as a barrier, and it's a flux will rise, but there was no flow. It very gradually used to drain out. So I said that in that case, why should we take the foundation so deep? It's not required because there is no flow. So we reduce the foundation. There is an existing bridge, rail bridge, which is working fine. We took at that level. A Nizamuddin bridge near New Delhi, second Nizamuddin bridge, which they consultants were right. They said that the bridge should be lifted to by 3 meters, and because to allow navigational traffic, and also taken, I think 2-3 meters deeper than the existing bridge. I said, if you take it deeper, what will happen to the existing piece, which is 40 meters away only? There is no need, and that bridge is perfectly all right, existing bridge. So there is no need. So, and there are between the Yamuna barrage near Delhi and this Kalindi Kunj barrage, there are at least 10 bridges on Yamuna. I mean, no one has been having that kind of a clearance. तो मैंने कहा कि सारे तो ऐसे ही जा रहे हैं, इसमें तुम 1-2 मीटर पर ले जा करके क्या करेगा? Not so. What I'm saying is all the codal provisions are not applicable. You have to see that what can be applied. So we should remember that, and no design can be for calamity. आपको and good engineering practices, universal practices for good design, and this always good to observe what are the already existing structures are behaving. So we go to the next one, please. Important aspects. इसके बाद वाला आइए, next one. Yeah. So I have already talked about some of the items in concrete and steel. In a girder, bearing is the most important. It should be well designed, regularly inspected. In Hooghly Bridge, this pendulum bearing, it cracked. So they called me. I said that why it has cracked, we should know. Because the other side was okay. So idea is to examine that bridge does not speak a lie. Human being may say that कि हमें आज ठीक हूं, बुखार लगा हुआ है, तब भी बोलेगा आई एम ऑल राइट. The human being can say that he is all right when he is sick, actually sick, and he will say that I am very sick, though he is very fine. But the breathers will not do like that. Breathers will exactly tell you what has happened. And I said that it means undue forces are coming on the pendulum for which it has not been designed. So let us go and see the expansion joint. And true and find that the expansion joint was jammed. That means nobody inspected the expansion joint. Nobody saw this, only crack ho gaya. So observation is very important. Crown of an arch bridge. He said that in Lucknow, the brick is falling. So ye bridge. I said that, have you heard of a arch? Arch is a compression member. How a brick will become loose and fall down? That means its motor has leached. So we repaired that bridge. Bridge is okay. So I am, if you remember the function of an arch bridge, you will say that it is not possible. Anchoring of a cable stayed bridge. Bhagalpur failure has been this. It has not been properly anchored. It failed during construction itself. End block of a PSC girder. Is a heavy, very high stress zone area end block. If you do not do proper concreting, if you leave void, it will fail. So this special type of concreting has to be and see what is the pattern of a design, and we should see during actual concreting that the concrete is flowing through the everything, wide windows to see. So tensioning is very important. See, wire, it function is of hysteresis. If you put a cable, stress it, say 100 kg per square, this one, and lower it, it will fall down because of these stresses. So if you are not aware of this phenomenon, so what we do, that supposing the stress, the force is required to be 100 tons, I take it to 110 or 20% high, 120, and then bring it down. So जितना loss होना है हो जाए, उसके बाद में then you block it at end. So these are small tricks which are, if you are aware of the process of relaxation, the relaxation theory of this, you will take care of all this. That is why I stated, read the important properties of the materials very well. Let's go to the next one. There should be no cold joint in the gutter. It should be normally done with a one go. But if you have, because of some reason, you have to provide a cold joint, have a kind of a sloping one, not vertical and or horizontal. Wide a sloping one and give enough kind of make a box hole for concreting of the next phase again. And good joint design is very important. Moolchand I had explained. Burdwan pylon was a 135 feet pylon. Burdwan steel pylon. So fabricated, made of plates. So we provided on the corner struts so that the angle between the two plates is 90 degrees always. A stiffness sort of thing. And a very accurate design calculation is not necessary. वो समझ लो कि कैलकुलेशन में आता है कि 3.28 square inch and provides 10 bars of 12 millimeter, and then it comes 3.26 unsafe, then provide 16 millimeter bars, 400 millimeters waste. This 3-4% is okay. We should not try to, because there are so many assumptions made in this one. So we did this in Manektala and underpass in Kolkata, and we allowed construction of this places. These are the typical slab beam joints. Next slide, please. I will only appeal that there is nothing to talk about. I have already said. You see how you can construct the joints which will be proof against rotation. There is a standard column and beam connection. And next one, please. This is the foundation, how they are constructed. And then next one, please. Next one, please. This is steel. The brackets are provided here. Brackets are provided with a stiffener in between. Allow it to be completely vertical. I have got a paper on this, how to deal with joints separately. Then next one, please. Discharge should be generally obtained from the gauging stations. In Narmada, they applied the formula, Chase's formula, root C, root A. I mean, वो तो जब लगाता है कि जब you do not have any other figure. Here, all the gauging stations, we should get the actual figures and get Sauer calculation also. Apply your mind by using this. If already an existing structure is standing, you should take that depth of foundation as okay. Remember one thing, no foundation fails in deep bridges, because of the bearing capacity. Failure is always against stability because of the horizontal forces. So we should consider do the stability calculation. If in bearing, it never fails. In a scourable bed, the scars are high, piled foundations are very, very unsuitable. We should go to the well foundation, or any protection work should be designed on the basis of local conditions, which I have to state it. I think I come to the end of my presentation. Thank you very much. If you have some questions, I will try to answer them. If there are any questions, I can answer them.
I have one question.
Yes.
You said the ultimate tensile strength is 19 kg per mm square. So,
Yeah.
you're talking about which section of the bridge, like the beam section, the column section? Which section?
No, 90, I was talking about rail.
Rail.
Yeah. Rail.
So this is maximum bending tensile strength of the beam.
Yes.
So thank you, sir.
Rail stresses. So I have not talked anything new. I'm just trying to develop that you can look at the things differently. Try to spend some time. और वो I was told that आजकल drawing नहीं बनाता है. I think people should be encouraged to use drawing. Use government of India's topo sheets instead of Google's drawing. The topo sheet has not so much of information. They should use topo sheets. Thank you very much.
Thank you so much, sir. For more questions, participant can write the questions in the chat box or mail us for answers. Moving forward with this, we come to the end of today's first session, Faculty Development Program. On behalf of the organizing committee and our institution, I extend my heartfelt gratitude to our esteemed resource person for sharing their valuable knowledge, insights, and experience with us. Thank you so much, sir.
Thank you.
Moving forward to our next session, it is an absolute honor and privilege to welcome our distinguished resource person for today's session on disaster risk management, Professor Dr. A.W. Kharche. Dr. Kharche is a highly accomplished academician, researcher, and administrator, currently serving as a principal and director of the prestigious Padma Shri Dr. W. B. Kolte College of Engineering in Malkapur, Maharashtra. With a deep core specialization in civil engineering, Dr. Kharche extensive research span innovative concrete strengths such as fiber replacement, geotechnical application of geogrid in the flexible pavement design, and the structural behavior of cold formed light gauge steel structure. This structural foundation directly interact with micro level disaster mitigation, retrofitting, and infrastructure safety engineering. Beyond structural mechanisms, his domain expertise actively covers sewage treatment, modeling, infrastructure safety, and sustainable structure practices aligned with global sustainable development goals. As an administrated visionary, he has successfully steered institutions through rigorous NBA accreditation framework, established vibrant entrepreneur development cells, and championed national level faculty development program on emerging technologies. Under his leadership, his institution actively drives community and campus resilience initiative through a specialized group like the Campus Disaster Management Club, making him an exceptional fitting expert to guide this FDP. Today, he will be bridging the gap between core engineering, sustainable design, and real world execution strategies in disaster mitigation. Ladies and gentlemen, please join me in extending a warm virtual welcome to our speaker, Professor Dr. A.W. Kharche. Sir, our respected director, sir, will welcome you, sir.
Thank you, sir. Very good morning. Good morning,
Good morning, sir.
everybody.
Namaskar, sir.
Namaste, sir. Namaste, namaste.
Very happy to see you, sir.
Yes,
It
yes.
has been a long time.
Yes, sir. I'm also very happy.
I welcome you, sir, in this program.
Thank you, sir.
Professor Dr. Kharche, sir, is an eminent professor in civil engineering in Maharashtra. And when I was a principal in Maharashtra in one of the college, sir was also principal in that university. And sir was one thing I share all the participants that sir was the senior most principal in that our I think 17, 18 principals group, and I was the junior most. This was the our one you can say uh, one type of another link. And sir came in our institutions some many times and attended in physical mode also. So, not wasting much of the time, I once again welcome you, sir,
Thank
and
you, sir. Thank you.
we will start this session, sir.
My voice is clear, madam?
Yes, sir.
I will just share
Completely
my.
audible and visible, sir.
चालू करू. ठीक आहे. Is the screen is visible?
Yes, sir, it is completely visible, sir.
Okay. And is it in PPT mode or in other mode?
Sir, it is in PPT mode.
Okay. Thank you. Good morning, all participants. Myself is introduced by organizer. I'm very thankful to organizer that they have given me opportunity to talk to you on the disaster risk management system. So at the outset, everybody heard the name of NDRF, right? Anywhere any disaster is took place, maximum time NDRF team is going and they are taking all the situation in their hands. So I will just give the first history of this. Share नहीं हो रहा है मैडम. Just Pandu. Next slide. Yes. Okay. Good. Prior to this, one more slide is there. One more slide, madam, please. Slide there, please. Yes. Thank you. Okay. So this is the history of our disaster management in India. In Bengal famine, that is 1770 to 1944. Britishers worked yes. Okay. Work to safeguard their business and taxation, not looking after the safeguards of the natives. This was the biggest problem. They were taking everything, business, tax, but they are not safeguarding the natives. Since independence till 1994, India had focused on responding to disasters with financial support, like food for work, etc. But international decades for natural disaster reductions, 1990 to 1994, focus shifted from response-oriented approach to addressing issues proactively. So, okay. So focus not responding, that is changes and approaches addressing to issue itself directly. From a Yokohama conference in 1994, establishment of capacity building institutions to focus on mitigation and preparedness. National Disaster Management Program launched by Minister of Agriculture. Earlier it was in the Minister of Agriculture. Then High Power Committee HPC from 1909 to 2001 constituted for establishing preparedness and DRR initiative, disaster risk reduction initiatives, along with exploring and recommending global best practices for mitigation and response. Then enhancement of disaster management, provide legal support to DRR and response activities. Hydro Framework for Action, HFA, from 2010 to 2015, adopted in 2005 itself. HFA was the global blueprint of disaster risk reduction efforts between 2005 and 2015. Sandy Framework for Disaster Risk Reduction 15 to 30, adopted in 2005-15, SFDRR is the first major agreement of the post-2015 development agenda with an aim to achieve substantial reduction in disaster risk and losses. Sustainable Development Goals, Paris agreements on climate changes, that is from 15 to 30, both the agreement along with SFDRR from the backbone of climate resilient and sustainable DRR. And then Asian Ministerial Conference for Disaster Risk Reduction. Honorable PM gave the 10-point agenda for DRR, disaster risk reduction, during this conference. That is the first ministerial conference post SFDRR held in New Delhi in 2016. These agenda points are guiding principles for DRR in the country. So disaster management of India and milestones. 1994, National Disaster Management Program is launched by Minister of Agriculture. Under this program, National Center for Disaster Management NCDM established in India, Indian Institute of Public Administration, and 18 other centers for disaster management established in states for capacity building. Responsibility transferred to Minister of Home Affairs MHA in June 2002 from agriculture to shifted to this Home Affairs. National Center for Disaster Management upgraded to National Institute of Disaster Management NIDM in October 2003. National Disaster Management Authority NDMA constituted in May 2005 and Disaster Management Act enacted in December 2005 itself. Again, National Disaster Response Force NDRF constituted in 2006. National Disaster Management Policy in 2009 and National Disaster Management Plan prepared in 2016 and then revised in 2019. Yes. So this is the hazardous states of India. India is vulnerable to almost all hazards. It is surprising that earthquake is in the area of 58.6% of land mass. We can imagine, or we can just think that only 40% around, which is safer zone for earthquake. Similarly, cyclone and tsunami is 76% of coastal line, means only 24% is in the safer side. Droughts, 68% of cultivable land. 68 किसको बोलते हैं? So only just 32% land is not there in the drought-prone area. Similarly, landslides and avalanches, that is 15% of the land mass. Floods and river erosions is 12% of land mass. So we can imagine hazardous is taking almost many part of this our country. Also vulnerable to chemical, biological, radiographical, geological, and nuclear disasters too. Hazardous, vulnerable, capacity, and disaster. So, disaster, hazardous source of potential harm or a situation with a potential for causing harm. A potential damaging event such as an earthquake, flood, cyclone, or drought. Exposure is for proneness to hazard, the preparedness of people, property, infrastructure, and ecosystem in areas where hazardous many causes. Whenever the degree to which people, communities, or assets are susceptible to harm when exposed to hazard. A village located increasing, 100% disaster will be reduced. So, our government is going for building the capacity, going for increasing the capacity. So, hazardous may inevitable, but disasters can be prevented. So, this is the disaster definition as per DM Act 2005. Disaster means a catastrophe, mishap, calamity, or grave occurrence in any area arising from natural or man-made causes, or by accident or negligence, result in substantial loss of life or human suffering or damage to, and construction of property or damage to, or degradation of environment, and is of such a nature or magnitude as to be beyond the coping capacity of community of the affected area. So sometimes man-made is also dangerous, hazardous for us. Few days or a few months back on Pune Mumbai highway, there was a tanker which was taking the gases. He just got the accident. And due to that accident, around 12 hours traffic jam was took place. So 100% it is due to the man-made problems. So this is the one of the best slide of today's presentation, which gives the disaster management cycle. So there are two parts. One is pre-disaster, another is the post-disaster. The government shifted his aim from instead of post, they are going for nowadays for pre-disaster. So first point is preparedness and capacity building. As in the last slide, I said that as capacity building is increased, automatically hazard will be reduced. So preparedness refers to measures taken before a disaster occurs to ensure an effective response and minimize loss of life, property, and livelihoods. For example, early warning system. In case of flood or cyclone, we can go. Evacuation plans. We should prepare the evacuation plan properly. Mock drills and disaster simulations. Emergency communication system. If you are depending on only mobile, and then it is just difficult for us to communicate. Then stockpiling essential supplies, training first responders. So that is also a major preparedness areas. Similarly, capacity building. Capacity building refers to the process of developing knowledge, skill, resources, institutions, and capabilities that enables individuals, communities, and organizations to prevent, prepare for, respond to, and recover from disasters. Similarly, training disaster management personnel, community awareness program, strengthening local institutions, developing disaster resilience infrastructure, and enhancing technical and financial resources. So it's all comes under capacity building. Relationship between these two, that is between preparedness and capacity building, based on their specific hazard or emergencies. For example, training villagers in the first aid and search and rescue is a capacity building. Training village in first aid, search and rescues is the first capacity building. Conducting a flood evacuation drill before the monsoon season is a preparedness. You can give the capacity building, but whether they are prepared it or not, you have to check it. Second point is mitigation. That is prevention and risk reduction. Mitigation refers to the measures taken to reduce or eliminate the adverse impact of hazards and disasters before they occur. So in that case, the prevention is the one part. Actions aimed at avoiding the occurrence of a disaster or preventing its harmful effects whenever possible is an example. Restricting construction in the flood-prone areas. We have seen the situation in the case our Kedarnath. Maximum houses were constructed in the flood zone areas. So 100% when floods comes, they flows in. Second thing, enforcing environment regulations. Strictly, we must follow it and see that others should follow it. And last one is preventing deforestation to reduce landslides. Similarly, second is the risk reduction. Action that reduces the likelihoods or consequences of a disaster when complete prevention is not possible. For example, earthquake resistance building design. It is a risk reduction. If we construct the houses with the earthquake resistance, then it is possible. Similarly, flood embankments and drainage system is also important for flood reduction. Cyclone shutters. During the cyclones, if we go for cyclone shutters, it is again very good. And land use planning and zoning regulations. That is also important, because if we are not restricted to land use planning, it is not possible for us to go ahead with the regulations. So, in case of hazards, what may be the mitigation measures? For example, earthquake. Earthquake resistant structures, flood, embankment, and flood plan zoning. In case of cyclone shelters and coastal plantation, that is also important criteria. And in case of droughts, rainwater harvesting and watershed management is a major role for water. It is surprised to note in our Maharashtra and Vidarbha region, where maximum numbers of farmers are doing the suicides, because even they try to take the borewell, you'll surprised to note it is 800 foot or around. Sometime even it is not possible to get water at 800 foot. So no water, no rainfall. So farmers are going for suicide because there is a more number of death. उनके ऊपर इतना कर्ज हो जाता है कि that cycle is not possible to complete. So simple summary: mitigation equal to prevention plus risk reduction. So this is the pre-disaster points. If you go for post-disaster, in that case, our response and relief is the first point. Response and relief are immediate actions taken during and immediately after disaster to save lives, reducing suffering, and prevent further damages. Response refer to the immediate action. For example, search and rescue operations, evacuations of affected population, emergency medical assistance, firefighting and emergency services. You can just recall your memories. Just few days back only, the fire incidents take place in the Delhi. And last one is emergency communications and coordinations. That is also very important, because in the Bhuj region, when some of the doctors visited for helping the persons, they found that everybody is coming over there, putting lot of materials, food, etc. But there is no proper distribution. So all the villagers, affected persons, they were not in position to use it properly. And it is merely wastage of money and everything. What do you mean by relief? Relief refers to the short-term assistance provided to the disaster victims to meet their basic needs and alleviate suffering. For example, food and drinking water distribution. As I already told, you will surprise that during whose victim, Bisleri waters are floated like anything. Even the visitors take the bath by using the Bisleris. Then temporary shelters, that is also in the relief. Medical aid and medicines, yes, required. Clothing and essential supplies. And last is the financial assistance and compensation. That is also plays important. So what is different between response and relief? So response is based on immediate emergency actions, and relief is assistance to provided to victims. Second point, response focuses on saving lives and controlling the situation. But in case of relief, focuses on meeting basic needs and reducing suffering. And in case of response, includes requisites, evacuations, and emergency services. And in case of relief, includes flood, shelter, water, medicine, and aid. So what is the simple summary? Response is for emergency action and relief is for immediate assistance. Right? For example, during a flood, what is the response? The accused teams evacuate the peoples, those who are suffered. In the case of relief में क्या करेंगे? Food packets, drinking water, medical care, and temporary shelters provided for affected families. So this is about the response and relief. Second point in the post-disaster recovery, rehabilitation, and reconstruction. These are the post-disaster phases aimed at restoring normalcy and building resistance against future disasters. Recovery means what? Recovery is the process of restoring and improving the livelihoods, health, social systems, economy, and infrastructures of the affected community after a disaster. For example, restoring electricity is the recovery, water supply, and communication system. Second, reopening schools and hospitals. This is also recovery. Resuming economic activities, again the recovery, and providing livelihood supports, that is comes under recovery. So rehabilitation means what? It refers to the short to medium term measures taken to help affected peoples and communities return to a functional state. For example, temporary housing, repair of damaged roads and public utilities, psychological counselings and social supports, restoration of livelihoods and employment too. What is the objective? To help people again their normal lives as quickly as possible. And reconstruction refers to the long-term rebuilding and improvement of physical infrastructure and community systems damaged by disaster. For example, rebuilding houses, schools, and hospitals, constructing earthquake-resistant buildings, reconstructing roads, bridges, and public infrastructures. Adopting Build Back Better principles. Build Back Better principles. So, what is the objective of reconstruction? To create, suffer more resistance communities than before the disaster. So, what is the difference among these three? There is recovery, rehabilitation, and reconstruction. So, phase recovery, what it focus overall reconstruction, restoration of normal life and services. What is the time frame? Short to long term. In case of rehabilitation, focus is on restoring basic functions and livelihoods. Again, time frame is short to medium term. Reconstruction. What is the focus? Rebuilding damaged infrastructure and assets. The time frame is medium to long term because it based on the required damage to be reconstructed. So simple summary, recovery return to normalcy, rehabilitation restore people and services, and reconstruction rebuild infrastructure stronger and safer. So this is the disaster management cycle that starts from mitigation, preparedness, response, relief, recovery, rehabilitation, and reconstruction. This sequence represents the complete disaster management cycle from reducing risk before a disaster to build communities afterward. So this is the definition according to Disaster Management Act 2005. Prevention of danger or threat of any disaster, mitigation, capacity building, right? Evacuation, rescue and relief, and rehabilitation construction. That already in that, yes. So under disaster management, pre 2005, reactive response and relief centric approach was there. But now in shifted to disaster response, proactive, prevention, risk reduction, mitigation, and preparedness driven approach. So this is the major changes after the 2005. Here is circuit नहीं है? Here नहीं circuit ना? हाँ, ठीक. So Legal Entity Framework Disasters Management Act 2005. Central Government, MHA, Ministry of Home Affairs, that is the nodal ministry. State governments, that is disaster management divisions, and district administration, DDMA. So under the central government, NDMA, NDRF, NIDM, DG are there. In state government, SDMA, SDRF, SIDM is working. And at the district administration, DDMA is working. So maximum time we are offering the at district levels and to the central level. So Cabinet Committee on Management of Natural Calamity, CCMNC, Cabinet Committee on Scrutiny, National Crisis Management Committee, National Executive Committee, and State Executive Committee Chair. So this is the act in which different acts are done. So the total CCMS to oversees all aspects related to management of natural calamities. Where are the natural calamity? CCMNSC will be one. In case of CCS, evaluations from a national security perspective is an incident has the potential security implication. NCMC, Chairman, Cabinet Secretary, to oversee the command, control, and coordination of the disaster response. And in case of NEC, Chairman is the Union Home Secretary to coordinate, monitor implementation of National Disaster Management Policy, to prepare National DM Plan, and to assist NDMA in discharging discharges of the functions. So NDMA constituted in 2005. Honorable PM is the chairman. Total 9 members. Mandate to lay down policies, plan, and guidelines. NDRF raised in 2006. DG is head, offers and troops from CAPF. Mandate for response. NDM constituted in 2005. ED is head, academic body mandated for capacity building. SDMA, as per the state government notification, Honorable CM is the chair, total of 8 members, mandate to lay down state-specific policies, plans and guidelines. And DDMA, as per the state government notification, district magistrate or district collector is the chair, total number of 7 members, responsible for planning, coordination, implementation of state-led policies and guidelines. So nodal departments for disaster, earthquake or tsunami, nodal ministry is Ministry of Earth Science. Disaster may handled by Ministry of Home Affairs. Maximum time disaster handled by MHA. Flood, Ministry of Water Resources. Cyclone, India Meteorological Department under Ministry of Earth Science. Forest fire and industrial chemical disaster, Ministry of Environment, Forest and Climate Changes. It is under Ministry of Environment, Forest and Climate. Landslides, Minister of Mines. Avalanches, Minister of Defense. Similarly, disaster, drought, hailstorm, and pest attack, Ministry of Agriculture and Corporation. Same will be the they will be handled by nuclear disasters. Nodal agency is Department of Atomic Energy and handled by MHA and Department of Atomic Energy. And last is biological in case disaster, Ministry of Health and Family Welfare. You know the latest academic in 2019, right? The China and other countries also affected due to this virus. So National Policy for Disaster Management 2009 provide the framework roadmap for handling disasters in a holistic manner. Covers all aspects of disaster management, institutional, legal, and financial arrangements, pre, during, and post disaster actions to be taken, capacity development, knowledge management, and research development. So National Disaster Plan, NDMP, the National Disaster Management Plan, duly approved by NDMA, was released by Honorable Prime Minister on 1/6/2016 with an aim to make India disaster resilient and significantly reduce the loss of lives and assets. The plan was revised in 2019 based on the 4 priority themes of Sendai framework. This plan covers all phases of disaster management and spell out the roles and responsibilities of all levels of government in matrix format, which assists in preparation of disaster management plan for the ministries and department of government of India, as well as preparation of state and district disaster management plans. Forecast warning. So, if disasters like cyclone, nodal ministry or agency is India Meteorological Department. Tsunami, Indian National Center for Ocean Informative System Services. In case of floods, Central Water Commission. Landslides, Geological Survey of India. Avalanches, Snow and Avalanches Study Establishment. And in case of heat and cold waves, India Meteorological Department. Again, you are surprised to know that in Maharashtra, in India, in Vidarbha region, the temperature goes up to 48 degrees Celsius. You can imagine what happened if such types of heat waves, if you are not taking the precautions. So national preparedness policy, NEOS functions in North Block, New Delhi, 24/7 to monitor the disaster or disaster-like situation. Issues advisors to the concerned state based on warning issued by forecasting agencies. During southwest monsoon, daily season reports are prepared and sent to all concerned. During the calamities of severe nature, special situation reports are also prepared and issued. National Institute of Disaster Management. Considered in DM Act 2005, Premier Institute for Capacity of Development, nodal responsibility for human resource development, capacity building, training, research, documentation, and policy advocacy in field of DM. Strategic partnership with focus ministries and departments of central, state, and local governments, academic researchers, and technical organizations in India and abroad, and other bilateral and multilateral international agencies. NDRF, every time you might be heard this word in all the news, etc. In 2016, for the purpose of specialties respond to the threatening disaster situation or disaster. NDRF has presently 16 battalions raised from Central Armed Police Forces. The selection is from Central Armed Police Forces. To reduce the response time, 28 teams per bodies of NDRF station at different places. We'll see it in the areas of response of the battalions. MHA, Ministry of Home Affairs, has approved the SOP stipulating specific action taken by NDRF battalions for responding to disasters. NDRF Academy is established at Nagpur, Maharashtra, by merging National Civil Defence College to synchronize training activities of other sectors and to ensure optimum utilization of available resources. Each NDRF battalion is equipped with 310 state-of-the-art of the equipments. So NDRF battalions for responding to disasters, and the key features: 16 battalions strategically located across the India. Similarly, Central Armed Forces like BSF, CRPF, CISF, ITBP, SSB, and Assam Rifles Jawans are taken, officers are taken from it. Each battalion consists of 18 specialized search and rescue teams trained to handle earthquake, flood, cyclones, landslides, building collapses, right? Forest fires, and other man-made disasters. Major functions of NDRF: search and rescue operations, evacuations of affected population, medical first response, civil and humanitarian assistance, disaster preparedness, and mock drills. The best motto of NDRF: Apada Seva Sadaiv Sarvatra, saving lives and behind it. Apada Seva Sadaiv Sarvatra. So this is a deployment of NDRF teams everywhere, right? Wherever the chances of anything disaster it took place. Right from Hyderabad, Odisha, all these Maharashtra, Guwahati, Noida also there, Gujarat. This primary responsibility to respond to any disaster react with the state governments. MHA has been pursuing with all state UTs to their own state disaster response force on lines of NDRF. As of now, all states UTs considered SDRF except Goa, Telangana, Jharkhand, Delhi, Andaman and Nicobar Island, and Chandigarh too. So these are the states where the state disaster response force is not being established. Financial Commission resolutions developments for CRF NCCP 2010, SDRF NDRF 2010-20, SDM F 100, SDRF emergent funds for SDR. So SDRMF 100%, that is around 160,000 crores. Out of that, 80% is for SDRF and 20% for SDMF. Out of that, again, the distribution, if it is a bigger one, then response and relief 40%, recovery and reconstruction 30%, and preparedness and capacity building is 10%. So this is the mechanism for NDRF 100%, NDRF 80%. Similarly, NDMF is 20%. So this is the chart showing what is their services based on the money distributed by central government. Responsibilities. Section 36 and 37 of Disaster Management Act specify the responsibilities of ministries, department of the government of India, and spell out them to act to be taken by ministers. Prepare a disaster management plan, review and update the plan annually, forward a copy of plan to central government to eventually to be forwarded to NDMA for approval, furnish status report regarding the implementation of the plan to NDMA as and when required. So under this disaster risk reduction, better preparedness, effective coordination, effective communication, and last mile connectivity, improved response, mainstreaming, and build back better. So these are the measure points. But Honorable PM, the 10-point agenda for DRR, disaster risk reduction, very important, because this is the reduction prior to any disaster. So in his inaugural speech at the Asian Ministerial Conference on Disaster Risk Reduction, AMCDRR 2016, held in New Delhi during November 2016, has incorporated in the NDMP. The 10 key elements consist of the following. Number one, all development sectors must imbibe the principle of disaster risk management. I will quote one of the example. In a simple water treatment plant, a leakage of chlorine causes a disaster in that area. And even we could not think that how chlorine gas is dangerous for the other people. So all development sectors. Similarly, second point, risk coverage must include all, starting from poor household to SMEs to multinational corporations to nation states. So the disaster is not only for rich people, but Honorable Prime Minister said also for poor households also we must risk coverage must be included. Third one, women's leadership and greater involvement should be central to disaster risk management. Why the women are required to give them the training? Because maximum time we'll find that in case of disasters, the more number of sufferers is women. So if we train them properly, naturally they will at least save themselves and at least, if possible, they can save others too. Fourth one, invest in risk mapping globally to improve global understanding of nature and disaster risk. Fifth point, leverage technology to enhance the efficiency of disaster risk management efforts. Sixth point, develop a network of universities to work on disaster related issues. Seventh, utilize the opportunities provided by social media and mobile technology for disaster risk reduction. Yes, very nice. But sometimes the mobile user is in only they are taking the videos and photographs of disaster. No doubt, always there are plus and minus point. Due to that, at least other people will come to know that disaster is took place at such and such place. Though they may not in position to help, but 100% it will be helpful. Eighth point, build on local capacity and initiatives to enhance disaster risk reduction. Ninth point, make use of every opportunity to learn from disasters and to achieve that there must be studies on the lessons after every disaster. हे कोणतं गेलं होतं आपण 19 काय आलं होतं? So same thing in 19 कोरोना ने हमको बहुत कुछ सिखाया. We learn a lot. This Zoom meeting is also a gift from the corona. So 100% there must be studies on the lessons after every disaster. And last point, bring about greater cohesiveness in international response to disaster. So that's all from my side. Though it was completely for disaster, but for it as environment persons, for structures, also it plays a important role. So that's all from my side. Over to you, madam. Stop sharing.
Hello,
Sir. Yes, sir.
sir. आप एंड हो गया सर?
हो गया सर. End हो.
So I think our participants were from all over India in this program, sir. And this IST has granted us, sir, this program. Only 30 institutions have been granted, sir, in all over India.
Great.
In
Very nice.
this particular, sir, program.
Yes.
And
Yes.
yesterday, Ali sir, our executive secretary of IST, himself confirmed this. Ki in
Great.
Bihar and Jharkhand, only this institution among private and government selected.
Great. Great. Great.
Yes,
Very nice. You deserve
all
for it.
these are
You deserve for it.
and your guidance and all these things and our training in Maharashtra, of course, these things are there, and that I want to convey to our participants also that
Yes.
these things are very important in our career. Participating in a program very sincerely, understanding. Now, as our Honorable Kharche sir said that after COVID, many things have been changed. So this is the you can consider it's a boon in disguise that due to this online session only we are able to
Yes, indeed.
taking this very good session and training and interaction. In our days, sir, for IST, STTP program, we had to go to travel at least 200,
Yes,
300 kilometers. Yes, sir? At that
correct,
time,
correct.
when in Segaon was conducting or sometime Kolhapur is conducting. So
Yes.
I remember, sir, I went to Surat for our textile engineering FDP. I stayed
Mm.
there for 1 week, and people from South India himself they used to come after telling 2 3 days. The slate 10 words was that time were
Yes,
slow, so we reached to some place and uh, gone through that FDP, and that was very compulsory for promotion
for
for
promotions.
particularly senior lecturer, etc. So now this is also today also it is very relevant, and the name has been somewhat different in that, but the thing is same. So I hand over this to uh, uh, Professor Sanaj Madam to end officially this
Yes,
session.
Thank you so much, sir. As we conclude this session, let us once again express our sincere appreciation to our esteemed speaker for an engaging and enlightening presentation. The knowledge and perspective shared today have undoubtedly added great value to this faculty development program. We shall now adjourn for lunch break. Participants are requested to kindly join in again by 2:30 so that we may commence the next session as scheduled. Thank you for your gracious presence and active participation. Have a pleasant lunch break, and we look forward to meet you again in the next session.
Happy Burma, Doctor.
The next session will be Dr. R.P. Verma, sir, Head of Department and Associate Professor, Dean ANA
In civil engineering.
in Civil Engineering.